Hello everyone, I am Shuputra Pancha, Assistant Professor, Department of Computer Science and Engineering, PADS VP Dr. PG Halkatti College of Engineering and Technology, Vijaypur. In the last class, I have discussed the taxonomy of cryptanalysis and cryptography. So in that we have completed module 1. So very basic steps we have discussed, different techniques for finding the deferred text with the plain text and the key is given. So now in today's session, we will be moving to the next module, that is something about hash functions. So what is actually hash functions? There is a quote here written, so try to understand this. I'm sure, so maybe my memory only works one way. Alice remarked, I can't remember things before they happen. It's a poor sort of memory that only works backwards, the queen remarked. So what sort of things do you remember best? Alice ventured to ask. Oh, things that happened the week after next, the queen replied in a careless tone. So what actually hash functions is, so it is totally one way. If we find out a hash of some data at sender side, at the receiver side he has to the receiver has to compare the values with some different data. That is what it is, purely one way. It is computed at one end, and at the other end it is compared with the different values. Once again the hash values will be compared calculated at the receiver. That is what the concept known as hash functions. Using hash functions, so once again what we are trying to do here is we are creating the data in a we are sending the data in a complex manner, that is the form of ciphertext. So that's what from your book it comes with chapter 5, that is hash functions. Something is written here, hash functions plus plus. So that plus plus in the sense, along with hash functions we will be applying cryptographic concepts to hash functions. Already you have studied little bit about hash functions in the previous subjects and all. So hash function motivation. So what is actually the motivation? Uh, I think in the last class I had discussed there are three different actors will come under INS throughout this entire subject. So what are those three different actors? One is Alice, that is the authorized sender what we are going to consider uh, for our data and all, for sending, for creating encryption and all. And another one is Bob, which is at receiver, who is also a authorized receiver. And the third person will come this is Trudy. Trudy is always acts as a hacker. That's the third person in between. So he will come in between Alice and Bob. So these three are factors will come through the entire subject, that will be used for the purpose of encryption, decryption, keys, plain text, whatever. So now, as as I was discussing about hash function motivation. So what is actually the motivation? Assume that suppose Alice signs yum. Yum is a message here. Alice signs yum means he will write a signature on particular message. So what Alice sends is Alice sends yum and yes. Yum is a message and yes is a secret code to Bob. How actually she sends is actually Alice is a woman, right? Like that they have mentioned in the book. So how she sends is uh, Alice sends yum and yes equal to yes of yum with the Alice as a key to Bob. So what Bob receives is yum and yes. Yes, actually it is equal to what here? Yum of Alice. So that she will calculate some hash on that particular machine. Means very simple technique here. So what Alice does here, simply Alice only signs on M and sends message along with yes, that is signature, M and signature to Bob. Bob verifies that m equal to, so what, how actually that Bob verifies that message, this particular message only comes from Alice. Simple thing, Bob calculates a message, again he will sign on that, that is how he calculates this. Bob verifies that m equal to yes, that signature of yes of Alice. Once again he will check out with the same signature of already sent signature, that is m equal to yes of Alice. If it is correct, then what Alice can do here? Can Alice just send yes? So there is a question here. So you can think of this question: can Alice just send yes? If m is big, what happens? If m is big, m of Alice costly to compute and send. So if a particular message is very simple or small, then Alice can easily sign on that message and send it to Bob easily. But if it is big, then this particular factor costly to compute and send. That's what the different criteria. Suppose instead Alice signs, so instead of signing directly on message, what Alice does is, suppose instead Alice signs h of m, that hash of m. So you will calculate hash function of that message, where h of m is a much smaller fingerprint of m. So whatever the message which is bigger or smaller, so if we calculate hash of that particular message, then it comes with a compressive mode, compression mode. That is what signs. Yet instead of signing directly a message, what Alice does is she signs with h of m, where h of m is a much smaller fingerprint of m. That h of m is nothing but here hash of m. Alice sends, now in this case, what Alice sends is the modification. Initially, Alice sent only a message and signature. Now a little bit modification. Instead of sending only message and signature, what Alice sends here, Alice sends message and signature which comes with the hash of m, h of m of Alice to Bob. So this will happen only if the case if m is big. Bob verifies that. Now here again the same technique, verifies that h of m equal to s of Alice. So as I said, hash functions cannot be reverted back. Only he can verify the signature. That's it. Actually, hash functions are used for whether the sender is authorized one or not. What who is receiving, whether he is authorized one or not, like that. So that for that purpose, hash functions are used. The continuation. So now in the previous slide, so Alice, what Alice does, Alice signs h of m. That is, Alice computes s equal to h of m of Alice. Alice then sends m comma s to Bob. S contains h of m of Alice. That's the hash of that message. Bob verifies that h of m equal to s of Alice. What properties must now, the very important point, what properties must h of m satisfy? Suppose now comes the third person, that is a hacker in between Alice and Bob. Trudy finds m, so that h of m equal to h of, so how now with that, I think in the previous techniques, how Alice sends the message m to Bob for verification, yes, whether both are authorized sender or not, authorized sender and receiver or not. Now how Trudy finds that message, yes, he is claiming himself is a authorized sender. So how he tries to get that message and sends it to Bob. That is what information, what properties must h of m satisfy, so that there should not be so that Trudy cannot find such a hash function. Suppose Trudy finds m, so that h of m equal to, so what he can calculate is h of m equal to h of m dash alternative value. Then Trudy can replace m of m comma s with m dash comma s. So he will take alternate values m dash comma s. And what Trudy does is, does Bob detect this tampering? The question comes. What Trudy sends is, instead of m comma s, Trudy sends m dash comma s. Does Bob detect tampering? A very simple question. You can see no. since h of m dash is equal to h of m equal to s of Alice. So very simple here. In this case, uh, Bob doesn't detect tampering. Yes, what Bob thinks is, yes, this particular message came only from the authorized sender, that is Alice. But actually, Trudy interrupted in between and got the value of m and calculated h of m with h of m dash, what he assumed, and what Trudy tried to send the message that m of m comma s with m dash comma s, so that Bob doesn't understand it's a uh, tampered one. So it's because now here only hash of only messages have been sent. Now another modification to this hash. Now what we have to do is, in some cases we can detect with hash functions. So now the next concept what we need to do is, the answer for this question is, we have to calculate, we have to encrypt this hash and send it to receiver, and at the receiver end we have to decrypt it. So only the thing is what we have to do is, we have to calculate hash function first. Then once we calculate hash function at the sender side, we need to calculate encryption of that hash function. Then that encrypted data to be sent to the Bob, so that no 2D in between can decrypt. So that will be received as it is to Bob here. So only the thing we can do it. So that is what the next concept is. What we have to do is, crypto hash function will be applying cryptography on hash functions. So this is what little bit about hash functions. Now in the next class we'll be discussing how we are going to apply cryptography to such hash functions.